Hey everyone! I'm Freddie Func and I'm the maths dude for functions and calculus. Calculus. Woo! The very name conjures fear and dread in a lot of maths students. Well, today we're going to break that myth and make it simple. It's not a horror story, just a simple concept we need and use for everything we do. This is the first episode in our series. Enjoy the video. See you all soon. Let's have a look at our learning outcomes for the lesson. At the end of this lesson, you should be able to explain the concept of calculus. What is calculus? What does it mean? Identify and describe examples of calculus in our everyday lives. Calculus is all around us, in everything we do, we just don't realize it. Recognize those areas in our everyday lives where calculus is important and essential to help us function in a technological society. So what is calculus? What's all the fuss about? Well, calculus is a mathematical study of continuous change. Differential calculus, which you may know simply as differentiation, is the study of the rates at which quantities change. Differential calculus is concerned then with rates of change, and that's what you're studying at the moment. Specifically, how quickly or slowly things change, or how things change in relation to each other. For example, we could measure how quickly a balloon deflates when the air is released. This could be a measurement of how the volume of air in the balloon decreases over time, or we could also measure how the surface area of the balloon decreases as the volume of air inside the balloon decreases. Let's look at a simple example of a rate of change. If you walk 4 kilometers in 1 hour, what is your average speed? I know this sounds very simplistic, but it is an important example of what we mean when we think of rate of change. You were, of course, walking at an average speed of 4 kilometers an hour. Speed represents how quickly distance is changing over time. How far I go in whatever time it takes me gives us speed. We said we had an average speed of 4 kilometers an hour. But of course, we may not have been walking constantly at this speed. We may have started slowly, sped up a bit, slowed down, then sped up a bit again, and so on. In other words, our speed over the 4 kilometers may have varied, but on average our speed was 4 kilometers per hour. By creating a mathematical model of our walk, which is a mathematical function where distances covered during our walk vary over the duration of our walk, then we could use calculus to determine our exact speed at any point on our walk. This is why calculus is the study of continuous change. Rates of change may vary, and we need calculus to determine exact rates of change at any given point in time. This is called the instantaneous rate of change. Remember this, it's very important on your course. Now, you can pause the video and have a go yourself thinking about where you may encounter rates of change in your everyday life. I'll start the ball rolling. Brushing your teeth. The number of brush strokes per minute when brushing your teeth, believe it or not, is calculus. So, what areas in life can we use calculus? Well, we could use it in medicine, science and technology, finance, meteorology, engineering, software development. Anywhere else you might think? In fact, everywhere. Calculus is used in nearly every aspect of our modern lives. Why? Because change is a fundamental part of our technological society, and so is our need to measure, monitor, and predict change. Let's now have a look at an example where calculus is used in each of these areas. In medicine, for example, We can use calculus to determine the rate at which a drug is absorbed by our bodies. Do you think that when you take a simple headache tablet, for example, that the drug is absorbed right away, or indeed all of it at the same time? No. The pills are manufactured so that the drug is released and absorbed gradually over a specified time period. Calculus allows us to create the manufacturing process to allow this to happen. Science and technology. Well, launching a satellite into orbit requires the application of complex differential functions to predict the satellite's trajectory from the moment it blasts off on a rocket to its deployment in orbit around the Earth. Finance. If you're lucky enough to have a few euro to invest, unlike me unfortunately, then calculus helps investment brokers model the rise and fall of investments over time, and if you are very lucky with enough money, you may not lose your investment but see it grow and grow and grow. But don't be too optimistic. Meteorology. We are all familiar with the weather forecasts we see on our television screens every day. But have you ever wondered how these predictions are arrived at? Yes, you guessed it correctly. Calculus. Calculus allows us to model the progress of weather systems and make accurate forecasts of what you will expect when you walk out the door. Hopefully it's not too stormy out there. Ooh. Engineering. How do bridges that span distances of kilometers remain steady? Why do large high-rise structures not topple over in a storm? When designing structures, engineers use calculus models to carry out a structural analysis and subject these structures to rigorous computer testing before they are built. So hopefully if you're on top of one of them, it won't fall over. And now for the biggie. And this biggie is becoming part of our everyday lives. Artificial intelligence, or as it is commonly known as AI. Calculus drives the probability models which are at the core of every AI system. Yes, at its core, AI is based on the probability of something happening, and complex differential functions underpin those probability models. So where did calculus come from? Has it always been there, or did someone discover it? Well, in fact, two mathematicians claim to have discovered calculus nearly 400 years ago in the 17th century. You probably know one of them. They were Isaac Newton and Gottfried Leibniz, and both claimed that the idea was copied from the other person. Hey, easy on now, lads. There's no need for all of this. It is generally accepted that both scientists discovered calculus around the same time and independently of each other. It's weird, but it's true. So, what do we learn today? We saw that calculus is the mathematical study of continuous change, and we can measure how one thing changes in respect to another, such as distance changing with respect to time, to give us speed. We also saw that calculus allows us to measure the instantaneous rate of change. For example, identifying the exact speed we are travelling at any moment. We looked at where and how calculus is used in the world around us and discovered it is used everywhere we need to measure change. Calculus is one of the most important branches of mathematics employed in today's technological world. So, conclusion. Calculus is the mathematical study of continuous change. Calculus allows us to measure the instantaneous rate of change, and calculus is used in every walk of life. Anywhere change needs to be measured. Well, that's the end of our short presentation on calculus. I hope it enlightened you, and let's face it, it wasn't that scary, was it? Hey again everyone, thanks for taking the time to watch the video. We'd really appreciate a thumbs up. You can also help our mission to provide high-quality conceptual maths learning videos by completing a very simple and anonymous online survey. It won't take you longer than 3 to 5 minutes. You can scan the QR code or use the survey link in the comments. Thanks again and have another great maths day.